Good evening, YouTube. Today we're going to try the hairpin circuit with a 60-watt halogen light bulb submersed in water. And normally when you have electricity running through water, you have some form of electrolysis. And if you look very carefully at this bulb, there are bare open leads that are exposed to the water environment. You can see the bulb is just sort of floating there underneath the water. And again, we have this spark gap, the two 40 kilovolt capacitors. We're using a 30 gauge wire. It's about 1.5 feet or 2 feet long in each lead. We're going into the circuit above the capacitor. I'm going to disconnect one lead, and I'll show you another interesting phenomenon, that when we load the system, when we turn the system on, I will show you the amp draw as far as what the transformer is drawing. And when we load it with a light bulb, you'll see a change. And again, the question to be asking yourself is, normally when you apply load, what happens to the amp draw? And watch what happens here. And I think you'll find this quite interesting. So here we go. I'm going to turn on the system. Spark gap going. And this is drawing from an amp standpoint. Now we're going to load it. Now look at this. Isn't that just sort of fascinating? It's lower. Thought you might find that very interesting. It oscillates, but it does go lower than what the normal amp draw is. Again, what I'll do is I'll disconnect the load from this. Load is off. That's still going. There's the amp draw. Okay, so the question is, applying a 60-watt load to the circuit decreases the amp draw on the transformer. Again, this is not conventional. Thought you might find that fascinating. Enjoy.